In progress.
Okay.
Yes, since you already know about the basic waves, terms, and terminology, so we are not talking about that. We will continue with our new topic. So after intensity, there is a concept of property of longitudinal and transverse wave in your syllabus, but that is also a very simple concept. Yes, one topic was of that Doppler's effect.
Yeah.
Okay, so
So are we gonna do Doppler's effect right now?
yes, so basically, there is a concept of Doppler shift or Doppler effect, right? Both are the terms. So if they ask about Doppler shift, so that was the same because Doppler shift means because we are shifting source from one point to another according to the observer, right?
Yeah.
That's why we use the concept of Doppler shift or Doppler effect, and it is related to waves. But in our syllabus, we talk about sound because that is easily observable and easily understandable. Other waves will also follow the Doppler effect even in stars. So basically, the original scenario you already know that once we are having a source over here, so sound waves are going to be generated in the surrounding with equal
Yeah.
length, right? Because the source is at rest state, so we are having equal wavelength in all direction. And this is our source, which is this time. Okay, after that, because we need to first write about the definition, and since we already discussed about the concept related to it, so already we know about the concept or the definition for the Doppler shift. Basically, it is only related to the relative frequency, right? Because when sound source is going to be moved from one point to another, so there will be a relative frequency, right? That was not original, that was relative, because once a body is going to be moved, so things are going to be changed according to their position. So basically for definition, we just simply consider this one as the frequency change due to the relative motion between a source we are writing about source of, so we are writing source of sound or light, both are
Okay.
and an observer. So this is the conceptual statement for this effect, right? So if they ask about define Doppler shift, what is Doppler shift or what is Doppler effect, so you need to write this one, right? And we are having a stationary source over here. So this is a stationary source which is at rest state, and once it is going to move in any specific direction, so let's suppose if we consider toward right hand side, so it starts moving towards right hand side, so our values will be changed. We are getting wavelengths like this, narrow on the right, on the left hand side, right?
Yeah.
We are moving towards right hand side, this is the direction, and we are talking about one observer. Observer is placed over here, this is our first observer. So if we talk about the wavelength, so this wavelength will be greater, and this wavelength is a very short one as compared to the original. So it means that if we talk about the factors, so you know the factors that the speed of the source will be equal to Vs, and we also calculate the frequency for the source or frequency for the observer. And two more only important thing in this section, because most is related to the calculation part. because once the definition you just done with the definition, so you already have some concept related to the wavelength and frequency. So
Yeah.
basically in this situation, source is moving towards observer. Source is moving towards observer. And if we talk about the quantities, so quantities will be like, first one, your wavelength will decrease on right side and frequency will increase, right? And if it is moving up from the observer, so it will be reversed. Wavelength will decrease and frequency will, sorry, wavelength will increase, frequency will decrease, right? So when source is
Yeah.
moving towards observer, so these are the two. And if we consider the opposite situation, let's suppose source is moving away, source moving away from the observer. In this scenario, we are having reciprocal concept from the previous one. One wavelength will increase and frequency will decrease. And the one more important thing which is related to the formula only. So we just write the formula and just related to the factors of positive and negative sign. So this is the formula V over V plus minus Vs. And if we talk about the factors, so factors will be like, F naught is the frequency of observers, or in simple words, observed frequency. Frequency. So this will be observed frequency, and Fs means source frequency.
Yeah.
So Fs will be frequency of a source or a source frequency. And V is simply a speed of sound, or we are using light, so this is the speed of light. But we are talking about the speed of, and Vs is the, these are the factors and why we use and how we are going to use this positive and negative sign. So if we talk about the positive sign, so we need to use positive sign when source is moving away, right?
Yeah. And then the negative is for when it's going towards.
So if source is moving away from the, so we need to use a positive sign, positive sign, V plus Vs. And if a source is moving towards, so we need to use a negative sign, minus Vs, it means negative sign. Okay.
Okay.
So this is a very simple concept related to Doppler shift because you already know about all the things. So let's move towards the next one. Then after completing the topic, we will solve some questions related to polarization, because polarization is a detailed topic because there is a law related to it also.
The Malus law?
Yes, the Malus law. So basically, there are much tricky question related to polarization also, because angle is included over there. Okay, so if we talk about the polarization, so we know that this polarization effect is especially for the transverse wave, not for longitudinal wave, because in longitudinal and propagation is parallel, so that's why it is not applicable on longitudinal. It is only applicable for transverse waves because the particles are going to be vibrate perpendicular to the direction of wave. And we also discussed that in polarization process, if there are different orientation for light, so it is going to be in single orientation, right?
Yeah.
So that is the concept. So we may just simply use the concept like this: vibration of a wave are restricted to, polarization is a concept, so we just write in a statement form. So vibration of a waves are restricted to one direction is the concept of polarization. And one more important thing that we studied, that in transverse, waves are vibrating perpendicular to the direction of wave. So one more important thing in the polarization, that vibrations are still perpendicular, right? So it will
Yeah.
not be parallel. So it will always perpendicular. Vibrations are still perpendicular to propagation of wave, still perpendicular to the wave direction or propagation.
Wave direction and propagation.
Vibration and propagation of wave. Propagation of waves or direction. If you are using direction of wave, so you don't need to use propagation word. And if you are using propagation, so don't need to write the direction of wave.
Okay, so they mean the same thing.
Yes. Or you may also write energy transfer, because the main uh, concept of wave is to transfer energy. So you may also
Oh,
use word transfer of energy. Okay, so you already know about the example that how light is going to be polarized. Just draw a one diagram for the reference. Let's suppose if we are having multiple vibration in multiple directions with different orientation, like this. So if we are going to use a polarizing material, because we need to use a polarizer material to polarize it. So let's suppose this is our polarizing material placed in front of a polarizer. We are only going to allow vertical vibration through this polarizer. So when this wave is going to be moved from this polarizer, so our final orientation will be in vertical position only, like this. All other orientations are going to be blocked by the polarizer. So this is our polarizer material.
so it blocks out the other type of directions.
Yes, it blocks all other orientation because there is only a slit, or we can say that there is only vibrations that are going to be moved through this polarizer or this material, right?
So only the vertical vibrations are able to pass through.
Yes. So basically, there is only a gate for vertical vibration. There is no gate for other types of vibration. So only vertical vibration can easily pass through it, because gate is only open for the vertical vibrations, right?
Okay, so it polarizes the light, and polarization is basically like reducing the intensity.
Yes. It will also reduce the intensity because there is also a law related to it. So we will also discuss about that concept. And let's suppose
Yeah.
if this wave continues the vibration in forward form, and let's suppose if we placed an other polarizer.
Mm-hmm.
Suppose if we place an other polarizer but in different orientation, so now polarizer is going to be placed like this. in horizontal form, right? So if we continue
Okay.
the path of this wave, so after passing through this polarizer, we are going to get nothing after this polarizer, right?
Yeah.
Because it is rotated to 90-degree initially, because first it is in vertical position, then it is going to be rotating 90-degree. Now it is in horizontal position, and we know that vibrations, or the vibration which is in one orientation, so that is in perpendicular form. And now we consider horizontal polarizing material, so that's why vibrations are going to be completely blocked, and after passing through the polarizer, there will be no transmitted light, no transmission of light. So it means there
Okay.
is nothing, because now there is no gate for vertical vibration. There is only a gate for horizontal vibration, but problem is that we are not having horizontal vibration orientation, right?
Yeah.
And we also discussed that once we place the first material, so first material is known as polarizer, and the second material is known as
Analyzer.
analyzer. Good. So the first material is known as polarizer, and the second one is known as analyzer. uh, Analyzer means because according to this second material, we are going to is final intensity, right? Just like in this situation, that we placed an other polarizing material in horizontal position. So basically, it will decide that how much light we are going to observe after the second material. So that's why it is
Okay.
analyzer. Okay. So the next concept is related to the intensity, because we did already know the polarizing situation. So now we need to know about that what will be the intensity, or how we are going to calculate the intensity. So to calculate the intensity, we are having a very important law, that is known as the Malus law. Okay, so basically, in Malus law, it was stated that when initially light passes through the first polarizer, right? So it is going to be reduced to half of its original intensity, right? Let's suppose if the
Yeah.
intensity of light is 20 something, so it is going to be half, that will be 10, right? Because all orientations are blocked, only one orientation is allowed, so it means it is the intensity of the light is going to be half passing from the first polarizer. So first of all, that is only, we can say that a condition, that is not a law. So the condition will be like this. Let's suppose if unpolarized light of intensity, and the unpolarized light of intensity is equals to I naught, a polarizer. So the intensity, say that final intensity of the light, or the light from the polarizer, transmitted polarized light falls by a, right?
Right.
So this is the condition, that the intensity of light is going to be reduced to the half of its original value.
Okay.
And we already discussed about these terms, the polarizer and the analyzer. So that is important for Malus law, because now we are going to discuss about the angle. Now we are going to discuss about the intensity, right?
Yeah.
Okay. So let's suppose there is also another condition. Let's suppose if the analyzer, if we talk about the analyzer, because polarizer depends, it is independent because we can place in any direction. After placing analyzer, we need to calculate the intensity that will be the final. So according to that situation, if the analyzer has the same orientation, because that is also a condition, right?
Yeah.
Because we only discuss about the different orientation, but it is also possible that orientation will be same. Happen next, if the orientation of analyzer is same as just like the polarizer, as the polarizer, so what will happen? Intensity will remain same half or anything else?
I think it'll stay the same.
Stays the same, because now it is already allowed from the first polarizer, right? So it means
Yeah.
that the transmitted will have same intensity, that half intensity passing from the first polarizer, also from the analyzer. So the light intensity transmitted by the analyzer has the same intensity. Okay, in an analyzer, it is, I mistakenly write it Z there. So this is a second, we can say that type of situation that is going to be happen in the Malus law condition. But now let's suppose we talk about the initial conditions, that how it is going to be possible, or what are the consequences of Malus law. Second thing is, let's suppose if analyzer in any random angle or any different angle, right? Okay. So what will be next? So that is our Malus law, right? Now we need to use Malus law, because angle will may be anything for the analyzer, that is not specifically 90-degree always. So for that specific purpose, we use Malus law. It states that, okay, the statement in the inverted commas are the definitions or are the laws, right? If the analyzer is rotated by any angle theta with respect to the polarization, the intensity of light,
Oh, it's gonna be the formula with the cos.
yes, that cos theta. So respect to the polarizer, the intensity of light by the analyzer is equal to, actually what? It will be equal to I is equal to I naught cos square theta. And you know about that I naught is the maximum intensity, because we already discussed in the initial statement over here, the unpolarized light of intensity I naught. So I naught has the maximum intensity, because this is the original value of intensity. So this is maximum intensity, and that I on the right side is the value of transmitted intensity or final intensity, right? passing through.
Okay.
Light.
Is that the only thing about polarization? Like, is that it?
Yes, but we are going to solve the question, so there will be some difficulty in solving the question because there is angle included. So statements will be like some confusing that what actually they are talking about. So that is the problem. And this theta is the angle between polarized light and the transmitted degree, so that is not a problem. And one, if we want to talk about the SI unit, so the SI unit will be, we already discussed in last class the intensity. We discussed
Yeah.
SI formula over here. Okay, we didn't mention the SI unit. Okay, so basically the SI unit for the wave intensity is, we know the SI unit for power, that is watt, the area, meter square, right? So watt per meter square is the SI unit. So that is not a,
For, this is for which one? For the wave intensity?
yes, this is simply for intensity because we are talking about intensity, right? So you know
The
that
unit watt per meter square?
watt per meter square, because power per unit area is known as the intensity. So that's why watt per meter square is the SI unit for intensity. Whatever intensity you are calculating, it will remain same, right? It not depends
Yeah.
upon the condition. Also, we discussed that if the same orientation, we are getting the same intensity. And the second thing is, yes, we discuss also that we know that cos 0 is equals to what? Cos 0 will be equal to 1, right? And cos 90 is equals to 0, right? So it means we are getting a maximum value at 0 angle, and we are getting a minimum value at 90-degree angle, right? So what is the meaning of that? Let's suppose the meaning of this angles or these values are like this. Let's suppose if we first place, let's suppose first we consider for situation number 1, that is for cos 0 the maximum value. So for the maximum value we need to do like this. We first place a polarizer. Polarizer is in, and this is the only orientation allowed. And then we analyzer, and this is the orientation allowed by it. So now you observe that both orientations are same, right?
Yeah, so there's no change.
Angle, right? So angle will be 0. So in that situation, we are going to get a maximum intensity after passing through the analyzer. And the situation of cos 90 will be the opposite one. Now we need to rotate that analyzer through 90 degrees. So let's suppose it a situation like this. So it is going to be rotated through 90 degree, and now we get vertical vibration of particles through the analyzer. So it will be equals to 0. That will be the minimum. Okay.
Okay.
And rest of the thing depends upon the angle. Angle may be 45, 30, 27, 26, anything, right? Okay. Any confusion till now?
No.
Okay. So basically in wave, if we consider journal wave, so basically there are two chapter. One is related to wave, and second one is related to the superposition, right? Superposition contains basically the interference of light, the concepts related to the light. Okay. And this is related to journal wave. So basically in wave section, in journal we need to cover two chapters in AS, because questions are going to be combined from both topics, both chapters. So there are two chapters related to waves specifically. We also discuss in the orientation session about the chapters. So this is the end of the first chapter, only waves, right? Because you already know about the basics. So that's why we started from the new topic. Okay. If you go through the syllabus, so you will find all old things like wavelength, frequency, properties of electromagnetic wave. Both are perpendicular to the propagation, and the formula V equals to F lambda. Last time we also discussed that if you want to drive that formula, so that is also possible, right? And that is also going to be asked for 2 mark. Okay.
Okay.
And rest of the thing, just like the basic definition of wave, just like the basic definition of progressive wave, and all the basic concepts, so you need to know about the all definitions. So they may ask anything for 1 mark or 2 mark.
Yeah, so it's like easy questions which you can like get free marks in, but only you have to know everything from before.
So this is the end of our first chapter.